Today we are going to carry on with obtuse and reflex angles with the trigonometric functions. Yesterday we did sine, so today we're going to do cosine and tangent. The first thing I would like you to do, however, is pause this video and sketch the graph of cos x between negative 360 and positive 360 degrees. So between negative 360 and positive 360 degrees, please pause the video and have a go, and then unpause it and I'm going to draw it. So it's very similar to the sine graph. It actually looks exactly like the sine graph but shifted over by negative 90 degrees or positive 270 degrees. So it's going to look like that, and then symmetrical the other side of the y-axis. This is a little bit too low compared to that one, so I'm just going to change it slightly. So it should look like that, and then of course you need to mark on the key features. So its minimum is the same, it's -1 as sine x, and its maximum is the same as sine x is +1. This is 90, this is 180, 270, and then -90, -180, -270, and this peak is at 360, and this peak is at -360. So that is what the graph of y equals cos x looks like. And I'm going to save that for the questions in case I need it. Okay, so cosine of obtuse and reflex angles. It is a similar method, but it's not exactly the same. So the first thing we are going to do is we are going to, oh, this is my headphone wire. We are going to find the reflex angle x for which cos x equals -0.26. So the first thing we would do is put that into our calculator. So we're going to do cos inverse of -0.26. And if we do that, we should get 105.070 something. Now this is not a reflex angle. A reflex angle is between 180 and 360. So if we have a look at our graph, we've got an angle about here, 105, and we want an angle that is between 180 and 360. So we want this angle here. If we just look at the part of the graph that is in the positive x-axis, so this, you can see it is completely symmetrical about 180. So, given that this gap is 105 point something, this gap here should be 105 point something. So we can do 360 minus 105 point something, and that will give us this angle here, which will be reflex because it's between 180 and 360. So for cosine, we can just do 360 minus the angle that we've already found. And we get for this one 254.9 degrees to 1 decimal place. For some of the cosine questions, you won't actually need to refer to the graph or do anything additional. If we want to find the obtuse angle, so find the obtuse angle, for which cos x equals negative 0.75, we would do cos inverse of negative 0.75, and if we work that out in our calculators, we will get 138.59 to 2 decimal places. Now, an obtuse angle is an angle between 90 and 180 degrees. Well, this is already between 90 and 180 degrees. And if we check the graph of cosine, 138.59, that's roughly here. There isn't another value of x that would give us an obtuse angle, because this one is going into reflex angles, this same value over here. So this is already between 90 and 180. So actually, in this case, the answer our calculator has given us is the answer. We don't need to do anything. We don't need to look at the graph. We don't need to subtract from 360. That should give you enough to do the cosine questions. So you can either have a go at those now and then come back to the video for tan, or carry on watching the video all the way through for tan and then do all the questions at the end. Okay, so last one then is tan x, and as with the other two, I would like you to pause the video and have a go at drawing the graph of tan x, please. So again, we're going to draw it between negative 360 and positive 360. Now, I know, and hopefully you do as well, there are asymptotes on this graph at negative 90 and positive 90. So the place to start with this is this part of the graph. This gap, because this is 90 and this is negative 90, this gap is 180. So the next time we have an asymptote is at 270, not at 180. This gap's 180, so this gap is 180. Remember that it is a repeating graph. And then we've got these midpoints. So this is 180 here. This is negative 180 here. So this will be negative 360. This will be positive 360. And it's just the same pattern over again. So that is what the graph of y equals tan x looks like, and that these are going up to infinity and down to negative infinity. So for our example question, find the obtuse angle for which tan x equals negative 10. So, same method, tan inverse of negative 10. We're going to put that in our calculators, check what we get, and we will get negative 84.29 to 2 decimal places. Now that is acute because it's less than 90. So 84.29, that's about here. So there-ish. So any angle on that same y equals something line will give us an angle that gives us tan x equals -10. Oh, what have I done wrong, everyone? That's a -84.29, so let's ignore the orange line I've just drawn. No, 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 no. And draw it in the right place, shall we? Right, -84.29, so about here. So let's save that, so it's all of these values. And it's asked us for the obtuse angle. Obtuse is between 90 and 180, so that's going to be this one. How can we get from this value to this value? Well, the pattern repeats every 180 degrees, so we can just add 180 to this and it will move it up to this angle. So we'll take our 84.29, which is negative, and add 180. So we'll do -84.29, sorry, it's early, plus 180 equals 95.7 degrees to 1 decimal place. Okay, and that should be enough now for you to do the tan questions. So have a go at all of those, and if you get stuck and need any help, please let me know. I will either send you a hint on Show My Homework, or if you found it very tricky, I will record a video.